My name is PRADA. I'm the computer vision lead at Footprint Technologies, and today I'm going to talk about how we are unlocking the online shoe fitting via data-driven foot measurements and size recommendation at Footprint. More than 50% of all shoes ordered online are returned, and 3 out of 4 of those shoes are returned due to the wrong size. Is that we have developed an AI service. That first part is the mobile fit measurement. It works on all common smartphones. It has a cloud-based computer vision approach. And then we are using a DNA4 or US letter, a piece of paper, as a reference object to get the measurements done. Shoe dimensions database, that it has article-specific shoe dimensions, and we work directly with the manufacturers so they can tell us how different shoes fit differently. So we bring these two parts together, and then we have some matching algorithm that picks a perfect fit for a specific article. So we have the journey from the product detail page to cart, workwear boot, and then you get different steps via tutorial, and then once you open the camera, the user is at home, for example, or in a workwear center or whatever, you get fully guided with an interactive guidance until you can measure your feet successfully. Here we are just extracting foot features, and for that we use two images. One from the front, like we take it like that, and one from the back, so we can have all the foot reconstructed or measured with respect to that object. How do you know that your measurement algorithm is actually accurate? Or just to get one of those scanners here. This is a 3D laser scan that we bought, and we started to do some tests to measure the fit 10 times. And we decided, okay, let's do that exact same experiment with our app. We did exactly the same. We just measured 10 times in a row, and we measured length and width just to compare both of the things. We saw that there was a bit more deviation, but it was pretty stable. And what we saw out of 10 measurements, the deviation that we got, standard deviation, was roughly like around 1 millimeter. So for us, this was proving that we had some measurement algorithm that could output almost the same results every time that you could use. So we got all of these foot features, then we just input one article number, because again, we are matching against one article, and then we had the matching algorithm. This matching algorithm looks into the inner shoe last database, then we output a size recommendation. So we are treating the shoes or the articles independently to just collect data. So we did in 3 steps. First, we measure with our app. Then we measured with the 3D laser scanner just to have a verification done. And finally, we have some shoe fitting, and we had some answers from every tester, from 20 to 50 people every day. And we try to collect also metadata like age, height, weight, regular use size, fitting preference, etc. And the testers normally test from 2 to 4 sizes, and we're trying to understand why this size fits you and why it doesn't fit one below or one above. On the other hand, we also have the shoe lasts from the clients. We normally receive this last data from the clients as a mesh or as a table. So once we got all of that, we just start post-processing all of this data, and with all of this data, we just we gathered and we try to optimize the matching parameters, and we are trying to maximize the user's favorite size, meaning we are trying to optimize for the favorite size the user claimed to have. But for the study, it was from August 2023 to May 2024, and in total, there were 848 shoe recommendations from our side. Is that of 138 checkout events, meaning that they actually purchased the shoe. We saw that the return rate of Footprint users dropped their returns rates for non-Footprint users on the same period of time from 16 to 3.8. We are pretty happy with them. So the conclusions that we have with this methodology that I have just explained is that the recommendations provided are good, and they reduce drastically the returns for the clients.